Great. Greetings, everyone. It's fantastic to have you here today with us. I'm Danica Remy, president at B612, which is the home of the Asteroid Institute. Welcome to our 2025 Public Progress Briefing. Next slide, please. Today, you're going to be hearing from members of our team and one of our favorite friends. I'm speaking, we're speaking in the order of today's program. You'll hear from me first, then Dr. Ed Liu, Joachim, Alec, Nate, Kat, Delphine, and then Steve. Next slide, please. For those of you who are joining us for the first time and those who have been part of the journey for many years, I want to just give a brief high-level overview of what we do at the B612 Foundation. Our flagship program, the Asteroid Institute, brings together scientists, researchers, and engineers to harness and advance the computing and astronomy. Through our Atom platform, we develop open, cloud-based tools that help humanity discover, understand, map, and ultimately navigate our dynamic solar system. We also lead a wide range of asteroid education and public engagement programs that build the knowledge, skills, and readiness needed for humanity's shared future in space. Through initiatives such as the Schweickart Prize, recognizing groundbreaking ideas in planetary defense, and the Asteroid Day program, and an expanding series of talks, workshops, and public events, our community educates, inspires, and mentors the next generation of STEM leaders and future innovators. Next slide, please. At B612, we believe that science and technology are powerful forces for shaping a safer, more informed future for humanity. Over more than 20 years, that belief has shaped our work and delivered real results. From our founding in 2002 to our discovery announcements in 2024, B612 has grown from an idea into a global force for planetary defense and solar system discovery. Along the way, we invented the gravity tractor concept, led foundational planetary defense work at the United Nations, launched Asteroid Day as a global education movement, established the Asteroid Institute Fellows Program, built the Atom infrastructure to power large-scale discovery, and most recently, we created the Schweickart Prize to spark innovation in planetary defense. As a nonprofit, non-governmental organization, every step of this journey has been powered by private individuals like you. It's been a long arc of vision, persistence, and tangible results. Now, it's my pleasure to turn it over to Dr. Ed Liu, who helped co-found B612 and leads the Asteroid Institute program today. Next slide.
Thanks, Danica. I'd like to start by showing just the big picture of what we're trying to do. And what this is a view of our solar system as if you were floating out sort of around where Neptune is, say. So let's zoom on in and let's look at our solar system. There's the sun in the middle. All those little green and blue and white objects are asteroids. So the solar system, as we always point out, is almost entirely made up from a number standpoint of asteroids, not from a mass standpoint, but you can see the swirl of asteroids. The ones that are color-coded in green, that's the asteroid belt. That's between Mars and Jupiter. And then if you look inwards to the blue asteroids, the blue and white ones, those are ones that are called near-Earth asteroids, near Earth because they're near Earth's orbit, which we're zooming in on right now. This is an actual depiction of all of our data out of the JPL database. So these are actually all depicting real asteroids. And you can see just how many of these things pass very close to Earth. So we're following along on Earth. We're zooming in on Earth right now. You can see the moon outside the Earth, but there's the Earth. And you can see all these asteroids flying past the Earth. The important thing to note here is that this is just actually a tiny fraction of all the asteroids that are really out there, because the vast majority of asteroids we have not yet discovered and tracked. So these are just the known ones that I'm showing here. And the tools that we are building, the astrodynamics and cloud-based tools that we're building are things that are going to allow astronomers to fill in the details. The vast number of asteroids that are not depicted here, we're going to fill this map in, and we're going to help map the solar system. Important for three reasons. You can protect the Earth from being hit by asteroids. You can navigate through the solar system, and we can understand where the solar system came from, the growth and development of our own solar system. So that's the big picture of what we're trying to do. So we'll take the next slide here and then over to Joachim.
Yeah, thank you, Ed, for the lovely overview. Hi, my name is Joachim Muyens. I am a researcher with the Asteroid Institute, based at the University of Washington. And I think before we report on the progress we made in 2025, I think it makes sense to touch on what we came into the year with. And so in 2024, we reported on really the culmination of a multi-year effort where we built out the infrastructure, we built out the tooling, and we built up the expertise to discover asteroids that were essentially overlooked and hidden to traditional kind of discovery techniques. And powered by the kind of innate scalability that you can get in cloud computing, we ran a very specialized discovery algorithm to search 10-year-old data from 3 different telescopes, and we discovered about 27,000 previously unnoticed asteroids. This took an enormous amount of compute power, 8.5 million CPU hours. And so the way I like to think about it is if you only had a phone's worth of compute, it would take that phone 160 years to process those data and actually be able to discover those asteroids. But with our cloud platform, we're able to do it in just 5 weeks. And I think this is really remarkable because, for context, the kind of average yearly discoveries made by the astronomical community as a whole is about 20 to 30,000 asteroids. And so another way to think about this is by employing a new kind of algorithm and by leveraging our cloud platform that's on Google, we were able to, in just 5 weeks, discover about a year's worth of asteroids. And so with that, I'll pass it over to Alec, who's now going to describe some of the progress we made in the year since that announcement.
Thanks, Joachim. I'm Alec Kumjian. I'm the head of software engineering at Asteroid Institute. I am incredibly proud of the work our science and engineering team has done this past year, and we have a lot to show for it. Our Atom platform, if you're not familiar with it, is hosted on Google Cloud. It has grown considerably in both capabilities and depth this past year. Our unified observation dataset, which contains moving point sources from over 8 different telescopes, now contains 8.9 billion detections and is growing daily. This data set is the largest of its kind, and it's used to discover objects and extend the arc of objects in our solar system. This year, we also published our BigQuery replica of the Minor Planet Setters database. This is the world's official record of asteroid observations and orbits. This replica that we provide can be used by anyone to get fast and accurate results from over 500 million observations in the Minor Planet Centers database and the entire known object catalog. We also began hosting data from Rubin Observatory, which you can find on our B612.ai website. At this moment, this is the most convenient way to access astrometry and photometry for solar system objects detected by Rubin and submitted to the Minor Planet Center. We also added 2 new capabilities to the Atom platform: impact probability and trajectory optimizer. These 2 new services and our Precovery service are available for anyone to use, again, on the b612.ai website. We've also released our user dashboard on Atom, as well as a new API in which you can call our services from your own applications. My colleague Nate will talk more about these in detail. And if you have any questions or are interested in our open source tools, the Atom platform, any of your projects, we do love hearing from you. Please feel free to reach out. And with that, over to you, Nate. Next slide.
Yeah, thanks, Alec. So we're very happy to announce the launch of our public accounts on Atom this year. Now, I'll show a quick little video here that showcases it. First off, we've revamped the b612.ai website to clarify what we offer. So chiefly, that's easy access to the 3 services that Alec listed previously: our Precovery service, our impact probability service, which is new, and our trajectory optimizer service, as well as the data packages and assets that we publish, such as the BigQuery replica that Alec mentioned as well. Account creation and login are very easy. They can be done through email password or a Google account. And on logging in, users are brought to this dashboard with a list of historical jobs that they've run. Each of our three main services are accessible through the portal. These look much like previous demos that we had available, but they can be tracked and are private by default for users. We do allow users to make results shareable, though, in case they want to send a result to someone who doesn't have an Atom account. With everything in platform, we can more easily supply users detailed documentation to explain our open source tools, as well as the structure of the data assets created from their jobs. This new iteration of Atom is really useful for our power users. The ability to track and share previous jobs that have been run, as well as run queries via the API. These are all requests we'd received when we only offered the anonymous demo pages. It's also hugely useful for us. We can now more easily track usage, see how many unique users we have, and set some account level limits so that users don't use up all of our compute. I should note, along with this change, we've switched our previous demo pages over to now show sample results, give users a clear understanding of what's on offer if they create an account. Now, finally, this infrastructure investment sets us up very well for the future. As we add data sets and services, we have a place to deploy them and are able to get them into the community's hands more quickly. As we build up our user base, we're also building a network we can reach out to for feedback and beta testing of new tools. With that, I'll pass it over to Kathleen to talk about our work this year on 2024 YR4.
All right, next slide. Thanks, Nate. I'm Kathleen Kiker. I'm a software engineer at Asteroid Institute, and I'm going to talk about some of the real world science that we've been able to do with these tools. So it wasn't in our plan, but early this year, 2024 YR4 was discovered by Atlas and rose to an impact probability of up to 3% chance of hitting the Earth. Everything happened very rapidly as telescopes around the world pointed all their assets at this, but B612 was able to respond rapidly with the tools and services that Alec and Nate described. We were able to use our recovery service to find new observations in archival data and improve the orbit, track the impact probability with our Monte Carlo tool, and visualize the orbit and impact corridor, as well as the potential lunar impacts that you see here. And while the impact with the Earth was eventually ruled out, our models in the simulation that you could see still show a possibility of a lunar impact at about 4%. A little later in the year, at the IAA Planetary Defense Conference, we were also able to present our research on the Rubin Observatory using simulated data and the tools that we developed to determine how soon it would be able to discover potential Earth impactors like 2024 could have been. Our study found that Rubin alone would detect only about a half of impactors smaller than 140 meters, and many only months or days before impact. But we also found that the algorithms and the programs we use to detect these asteroids could have a big impact, closing the gap on those missing asteroids. And that's why we are now testing our impact probability code directly within Rubin's discovery pipeline. So new asteroids can be automatically analyzed for impact potential in near real time. And with that, I'll turn it over to Delphine to update you on the Schweickart Prize.
Thanks, Kathleen. So the 2025 Schweickart Prize this year honored Jordan Stone, a PhD candidate over at Imperial College London, with his teammates Kazuki Ikeya, Jim Buehler, and Yusuf Saleh for their proposal to create the Panel on Asteroid-Orbit Alteration, PAOA, an international body to anticipate and manage risks of unintentionally shifting asteroid orbits through human activity. Their idea highlights the growing need for coordination between science, engineering, and policy as human missions extend deeper into the solar system. This year's award was presented by Apollo astronaut Rusty Schweickart during Asteroid Day at Lowell Observatory and Meteor Crater, and was joined by sons Randy and Rusty B. Schweickart, the prize co-chairs. The $10,000 prize will help launch the PAOA effort and support the Space Generation Advisory Council Cosmic Future project, strengthening the global dialogue on planetary defense. This year's prize also included honorable mentions that recognized student teams from University of Colorado Boulder, University of Illinois Urbana-Champaign, and the University of Chile for their innovative approaches to impact communications and asteroid detection. Each year, the Schweickart Prize reaches more students worldwide, carrying forward Rusty Schweikart's legacy and inspiring the next generation to protect Earth from asteroid impacts. Back over to you, Danica.
Next slide. Thanks, Delphine. 10 years ago, I co-founded Asteroid Day along with Rusty Schweickart, Dr. Brian May, and Greg Richters to spark a global conversation about asteroids and planetary defense. What began as a grassroots effort modeled after TEDx and Earth Day has grown into a UN-recognized international event celebrated each year on June 30th. Our early 100X declaration called for a 100-fold increase in asteroid discovery and urged governments, scientists, and philanthropists to invest in better detection technologies. Since then, planetary defense has moved from the margins to the mainstream. Missions like NASA's DART and ESA's HERA mission now stand as leading examples of international cooperation. Public awareness has grown rapidly. Pew Research ranks asteroid monitoring as NASA's top public priority. And this year, the US Senate introduced a resolution recognizing June 30th as Asteroid Day. Today, Asteroid Day reaches classrooms and communities worldwide with more than 700 independently organized events this year alone. We're deeply grateful to the educators, scientists, and students and partners who have helped turn Asteroid Day into a lasting platform for global engagement and planetary defense. Next slide, please. Our work at B612 is made possible by the dedication and collaboration of our partners, scientific institutions, observatories, technology organizations that share our commitment to understanding and protecting our planet. Through these partnerships, we expand public education through collaborations with Meteor Crater and Lowell Observatory and many others. We advance the science of asteroid discovery through our close work with the University of Washington and the Rubin Observatory team. And we're especially grateful to our leadership circle partners, including Laurie Garand and Scott McGregor, Marianne and John Montram, Allison and Steve Krause, the Tito's Cheers program, and Google Cloud. Their leadership, support, and trust makes this work possible. Together, we're building a true community of discovery where shared knowledge sparks new ideas and accelerates progress in how we understand our solar system. Everything we've accomplished comes from partnerships and shared progress, and we are stronger together than any one organization could ever be. To reflect on that, please welcome our friend and colleague, Steve Smith, who has been an invaluable strategic advisor to all of us at B612. Next slide.
Yeah, well, thank you, Danica, and to our presenters and to the entire B612 team, thank you so much. I think it's very obvious that the work you've done is kind of magical and is really a gift to our 8 billion people on this planet. About 20 years ago, Ed Lu and Rusty Schweickart were sharing with a group of astronauts the lack of a map of our space environment and an understanding of how dynamic it was. And so with that, they also lamented the fact that there was really no government or international effort to both map and understand the dynamic environment. And so with that, they founded, of course, B612, and we're also lucky to have this magical gift now that's seeking really to protect the citizens of the world, most of which have no idea the situation we're in. I did have the chance to fly in space 4 times, and I can tell you that seeing the Earth from space changes your life. It looks just so beautiful in space. In fact, I'd like to encourage you to think of it as an island in an ocean, because when we look out of the window on our spaceships, it looks like this beautiful blue island in this vast, vast ocean of black space. And of course, it's obvious to us when we look from space that there's no borders. So we do have that feeling that we should all be more at peace and more tolerant with each other. But the other thing you realize, if it's an island, we should protect it. So of course there are islands on our island, but if you view Earth as an island, and I would encourage you to think about it that way, it also means we really need to protect it, both how we live on the island, but also as we fly through space, how do we protect the entire Earth and its population? And the image I'd like to leave with you is if you were to have a small blue marble like this, and were to go to a large field, for example, near your home, and we covered that field with a large piece of black cloth, and then we just took this blue marble and threw it randomly through the air, and it rolled to a stop somewhere on this big piece of black cloth. That's what we see from space, that it's this beautiful island in this vast environment. But as Rusty and Ed told us 20 years ago, there's a lot of things that put us in danger. And the citizens of the world hear about this occasionally when there's a close call of something flying by the Earth or something actually hits the Earth. So in any case, we do need to have this planetary defense knowledge, and no one's doing it at the depth that B612 is doing. The team that we have at B612 is incredible. I've had about 10 or 12 years now to get to know the team at many events. We've also traveled together in a couple of occasions, and we have the best of the best. And so for those of the members who are on the team online today, thank you so much for what you're doing. And to the audience that's listening, these are people who love science, love math, but are also mission driven. They've chosen a career that helps make the world a better place. And in this case, of course, they're actually protecting people's lives. And I've told Ed and Rusty a couple of times, I wouldn't be surprised in the future if the organization is considered for a Nobel Peace or Science Prize. So I think that'll be considered in the future. In any case, to the people who are on the presentation today, thank you for your interest. And for those of you who are donors, thank you so much. This is privately funded. I mean, it's really stunning to think that the best effort to protect our Earth is being privately funded. So thank you so much to the donors who are on the line today. And with that, I'll hand it back to Danica.
Next slide, please. Thank you so much, Steve. We're grateful for your leadership and your partnership and the perspective that you bring to our work. It's just been such a pleasure to have you on our team. And thank you to our team. I mean, as you said, all of this progress is due to their really hard work. And it's a really exciting time for us and our entire group as we're hyper-focused on delivering tools and capabilities that will continue to move the needle in the area of asteroid discovery and planetary defense. As I mentioned, we are especially grateful to our leadership circle and to our many founding and Asteroid Circle supporters, board members, and donors from 46 countries around the world. As Steve said, you make this work possible, and we count on each and every one of you. As many of you know, the second half of the year can make or break a charity, and we're building something the world has not done before, a dynamic map of our solar system that will support both exploration, discovery, and planetary defense for generations to come. And we're doing it with real momentum. The tools are working, and the discoveries are beginning to appear. But to keep accelerating, we need one thing. It's fuel, the fuel that comes from people like you, people who understand why this work matters and why timing is everything. If today's briefing inspired you, I invite you to join us. Your financial support directly shapes what we can achieve next. So thank you for being here and for being part of this journey. And with that, next slide. Let's open it up for questions. This is always one of the best parts of our briefing, and we're really looking forward to hearing from you. We have a great group today. If you haven't already, please submit your questions through the chat. You can also email them to info@b612foundation.org. And team, great. And so we have some questions already. Looks like one question: if an impact were confirmed imminent, do you envision countries coordinating an effective response, and how likely is it skeptics would hamper such a response? Who wants to? I'm going to hand that to Ed.
Well, a lot of this depends upon the timescale. So whether or not how we can affect an effective response depends upon how much warning we've got. So obviously, if things are just in the last few days, there's not much we can do. The only response you can really have is to maybe evacuate an area if you're down to those last few days, which is why the goal is, of course, to get years of notice. Now, whether or not countries can coordinate, I do think that's quite possible because of these agreements that have happened in the United Nations. There's two working groups, one which shares the data and one which is for planning of missions. And the various countries that have space capabilities have agreed to work together. Now, how that'll work in practice, we'll have to see, but I think that's a great first start.
Great. Next question is, what is the most technically challenging aspect of launching the Atom online platform? I'm going to give that to Alec.
Oh boy.
It's been a lot of work, right, team?
Yeah, so and I would open this up to the team in general. I would say that our technical challenges generally fall into two categories. There's kind of on the one side is more general software engineering. So that is just I like to think of it as shuffling bits around. So like you might do at any organization that's employing cloud services and deploying technology. So often, even with all the great tools and the excellent support at Google Cloud, sometimes even just running things at scale, you always run into various bottlenecks. I can't think of one particular problem in that category, but often it's just you have to do many, many, many small things in order to say run those 8 million CPU hours that Joachim was talking about. And then the other category I would put is really more on the scientific end of things, just algorithmically breaking down problems. We have a lot of interesting talks right now, particularly about Thor, that linking algorithm. The technical challenge there is uncharted waters and figuring out how to test things and test hypotheses and then how much compute do you even need to test those hypotheses? But I'd like to open it a little bit up to my colleagues just because they might have some interesting anecdotes or ideas on that as well.
Yeah, I guess one thing I might add is that I think there aren't a lot. Sorry. I think there aren't a lot of organizations like ours that kind of toe the line between a software organization and a research organization. We're not trying to do one-off scientific projects. We're also not trying to build sort of off the shelf SaaS, software as a service technology either. We're really trying to build out something that the community that can use, that uses novel algorithms, and so we have to kind of keep one foot in each world, the world of the very, very detailed, down to the last nanosecond precision level of scientific computing, but as well as we need scalable, fast systems that can actually be deployed at scale and used widely. So I think for a team of our size, I think that's one of the major challenges.
Yeah. And I would just add, I think very early on, we encountered a lot of problems with, on the open source side, on the science side, things like how to do conversions quickly, how to do, how to keep everything unified and clear. And I think just as we solved those problems, we sort of tied them into that open source package, and that kind of laid the groundwork to make things easier as time went on. Yeah.
Joachim, you want to put your
sure. Yeah, I mean, my 2 cents. So I think about this really from the science standpoint, and so on the discovery side, I think what Asteroid Institute is doing is completely new. Like, it's state of the art in that it's no one else can do it. And it's for me, it's really fun to be able to try to tackle those problems because you go in thinking we're going to solve this problem, which in our particular cases, we're going to try to find asteroids that have been missed by just employing a new cool technique to find them. And then on the way to solving that problem, you realize, oh, here's a tool that we just built that's actually useful to a whole other broader set of use cases. And then you go a little bit further, and then you build another tool that think, okay, this is actually really useful here as well. And so on the road to doing what's already a very complex and for trying to solve a very complex problem, we've been like pulling out all this really useful tooling. And so I'm always kind of taken aback by the fact that, had we not started on that road, we wouldn't have had some of the cool tools that we have now. And some of those cool tools that we build now are informing the solutions that we're employing to do the discovery problem itself. And so it is challenging, but from that challenge, I think we can really draw some really cool software tools and really learn some valuable expertise.
I've often said this before that the history of science, whenever a new observational or experimental capability has come up with, it always leads to surprising things. We see this in astronomy. Every time there's a new telescope and a new capability, Hubble, James Webb, Rubin is an example. These things come online, all sorts of things are discovered, but you shouldn't rule out that actually one of the capabilities that we're bringing to the forefront is on the computational side. So the same thing is going to happen as these tools become widely available on the computational side to do these types of calculations blazingly fast and at scale. There are scientific things that can be done, by smart people around the world at various, not us necessarily, but we're making them doable when you make these tools available to folks, and people will find ways to use them to push the frontier. And I think that's what we're really doing.
Great, thanks, Ed. So, connected question. Can you say a few words about who comprise the active community of Atom tool users and APIs, including who are the power users and what are they up to?
Is that for me again, or?
I guess it is.
Sure. I mean, I guess I could describe like categorically who our current active users are that we've seen. So one of the interesting things is that we recently transitioned from not having user accounts to having user accounts. So prior to this, we had our public demos, but unless someone reached out to us directly, we didn't necessarily know who who might be signing, who would be interacting with the hosted services. And so, categorically, we have, on the one end, we have, amateur astronomers who are really interested in helping identify additional observations of interesting or potentially hazardous objects. We've seen, we also have professionals in that arena. So, people at research institutions, people who work in planetary defense, people who work at observatories. We also see space mission planners and people from space mission companies using both our recovery and trajectory services, because they are interested not only in, scoping out mission possibilities, but they're also interested in potential mission targets, scoping those out, seeing if they can find more information, because we actually, even with the objects we do know, often we don't have enough information about where they are and what they look like in order to send a mission to them. So a wide variety of different users. We definitely have some enthusiastic power users in there who are, we have a handful of people employing the API, people that are in there, following up on objects pretty regularly.
Great, thank you. So another question that I'm going to hand over to you, Alec, is which telescopes are included in the Unified Object Database, and do you have any space-based telescopes?
That's a great question. So let's see. So our data sources currently integrated into the Unified Observation Dataset come from, the first one we added was from the Noir Labs source catalog. And that has data primarily from the Dark Energy Survey. And I'm not remembering the other instruments that are.
But there's two others.
Yeah, there's at least two others in there. We also have the Zwicky Transient Facility data, We have the Sky Mapper. I forget the official name of the survey. And we have all the Atlas telescopes as well. So I think that we have 4 coming from Atlas. So hopefully that was
And then
sufficient.
obviously we're working on Rubin.
Yes.
And
So
then we recently built the capability to add space-based, because there are space-based observatories up there. But we are, so an obvious one to integrate will become the NEOSurvey, NASA's NEOSurvey mission.
Yes. Yep. And we have queued up. We've done work on Catalina. We've done work on Pan-STARRS. Those both need additional work. Some of it from their end in order to be able to do the filters we need to do to get the specific subset of detections that we're looking for. Because we don't necessarily want every detection. We primarily just want the ones that are likely to be moving objects. And so those are some additional surveys which we hope to get in soon. And of course, as Vera Rubin, comes online, we will be very much looking forward to including that data set, which it won't take very long before it eclipses a lot of, most of the data available to date.
Great. Thank you. Thank you for that. And to our understanding, we have currently the largest unified data set of those images. We're always checking to make sure that we haven't missed someone out there who's doing something similar, but today we believe we do have the largest unified data set. Next question. Will asteroid 24 YR4 close approach in 2028 constrain its orbit for 2032 flyby and moon encounter?
Yes, actually, when it comes close to Earth, we should be able to either rule in or rule out a lunar impact in 2028. In fact, hopefully we can even do that sooner. The James Webb Space Telescope is scheduled in mid-February of next year, so about 4 months from now, to attempt to get observations of 2024 YR4. It is currently out in the asteroid belt. Actually, currently right now, it is behind the sun, so you can't see it. When it peeks out from behind the sun, they're going to make an effort to try and track it from the James Webb Space Telescope. And with those observations, we will either see an increase in the impact probably or a decrease. The reason is actually a large chance of it being increased because the moon is currently right about in the middle of the distribution of orbits of the asteroid. So as that distribution shrinks, assuming these observations are successful, then we will see a rise. Now, if it pushes the trajectory one side or the other, then it does have a chance that it could rule out a trajectory, but we'll have to see. We're going to have to just wait until mid-February and see if it's even observable or not. It's just on the hairy edge.
Thanks, Ed. Now I'm going to switch from technical questions to a people question. Delphine, can you talk about who can apply for the Schweickart Prize? Delphine is our Schweickart Prize program manager, and she's done a great job this year. Do you want to talk about who is eligible to apply for the Schweickart Prize?
Yeah, I will go ahead and answer that question. So the Schweickart Prize is for graduate students or recent postdocs who have graduated within the last academic year, who are working in fields that are related to planetary defense. And these fields don't necessarily have to be technical. They can also involve non-technical. For example, the one from this year, it was about policy and governance. So yeah, we're just looking for any graduate or recent postgraduate student who is looking to just develop an innovative idea on how to help advance planetary planetary defense and protect our Earth from asteroid impacts.
Great, thank you, Delphine. And then next up is from the next up, the question is, what's on our agenda for the next year or two? I'm going to give that to Ed in a moment, but I will certainly say our agenda is to raise enough money to continue to support this team as well as grow it, because there's not a shortage of the kind of technical work that we could do that would be highly beneficial to the astronomy community as well as to those people who care about planetary defense. So Alec, do you want to talk about the roadmap?
Sure. Yeah, we have a long list of things, of course, that we want to do, and it's always a question of prioritization. And new opportunities arise that you don't necessarily anticipate. So I would say that so broadly, some of the things we know that we are looking at are taking our discovery algorithms, mainly Thor, and looking to accelerate that, expand it with GPUs, and to potentially do a lot of unexpected discovery work with that. I'm not sure how much I can I can say about it at this point. There's also in the category of course, we want to continue to expand our data sets, and not just how much we have, but what type we have. And so we know we want to add some more foundational services to Atom, some of them very basic astrodynamics type things, so propagation, ephemeris generation, things like that. We also know that we want to we are thinking about how we can expand looking into characterization work of asteroids. So not all of this is confirmed for the next year, and in fact we are having a kind of like an offsite soon where we hope to talk a little bit more high level as we go into the next year. So let's see. Hopefully I didn't omit anything.
Well, I would summarize all that is to apply our algorithms and our services to the Vera Rubin data. That data set is going to be absolutely enormous. And we've seen glimpses of that. They've released small amounts of it, engineering test data from the early operations of this, but the spigot really turns on in 2026. And we need to be ready for that. So there's going to be a lot of things and there's going to be a lot of uses for our services on that data. And then over the next few years, where that leads, we'll have to see. I'm looking forward to another spigot coming on with the NASA NEO-SM mission. And I think if we're able to integrate all these data sets, we really can help build that definitive map of the solar system. And then provide the tools for everybody to use this combination of data sets from all these different observatories to move humanity out into space and to protect the Earth.
Great. Thank you, Ed. And thank you, team, for all of the work that you've done in the last few years to get us to where we are today. Thank you, everybody, for joining us. I especially want to thank our founding and Asteroid Circle members who joined the call, along with all of our recurring donors. Your steadfast support allows us to employ this talented team and continue the work. It's thanks to all of you that we have reached these major milestones in this past year. Our future discoveries and expansion of Atom's capabilities relies on your financial support. So thank you very, very much. And with that, our team, we would like to wish you all a happy holiday season and a happy new year. Thank you, everybody.
Hi, everyone.